So John has asked, although there are advantages in terms of representation, does the use of machine learning not risk creating black boxes that negates debate in design? And if so, how can we look to address this? It's asking me to, I'm not going to type this in, the Q&A box allows me to, but so this is actually, I think this is very much related to the question of the new discussions about ethics and AI, and particularly with respect to AI being able to explain itself. And I think there are two dominant approaches to this that sort of typify the two approaches to computation in general. One is that you look inside the black box. So you have AI where you're able to look inside at every point and explain exactly how it's coming to its decisions. And that seems to be one way to do it, which will work as long as the AI is relatively, it's simple enough that we can actually go inside and pick it apart. But the problem is when AI becomes so complex that you can't actually peer inside and look at, say, the latent weights of the hidden layer of neurons in a neural network or something like that. If it becomes too complex, then it's difficult, even if it could explain what's inside, to actually trace that back. So the other approach is that you say, well, the AI itself, we can never look inside it, but we have to come up with some sort of system by which we're able to get it to explain itself and develop some sort of system of trust that's much more like the way that we relate to one another in our society. So, you know, if we trust each other, if we have systems like courts of law where we stand up and defend ourselves, the judge can't look inside our heads to see if we're telling the truth, but we have systems that try to negotiate that and to negotiate those systems of trust. So there is another alternative that might be the case in terms of how we get multiple models with different points of view to actually negotiate with one another in design. Now, I don't know if this is the answer. I'm proposing it today because it's an alternative. I mean, one alternative, of course, is to have a trusted system of communication that we rely on, but another alternative is potentially to have lots of different models, each of which is potentially partial and imperfect, but together there's a system by which they can actually work together.
Brilliant. Thank you very much for this. So a few more questions. We just need to observe the time. New question, anonymous, Robert. Robert, can you see the question?
Yes, I can, yes. Yeah. I think it's a really, really lovely question. Well, actually, I think I would answer it in this way, which is, although I didn't want to make this a kind of review of my own work, what you may not know is that before I worked on RUCAPS and BIM, I worked on computer aids for design participation with Tom Maver at Strathclyde. And this is where we thought that the need for participation, lay participation in decision making, combined with accessible computing, could create systems where people could design their own buildings, bypassing, if you like, professional architects. And although we were doing it in the mid-70s with very, very primitive computer displays and interfaces, we did actually record, and I can send you a reference to this paper, where you know we got people who could express their ideas and reason about the spatial organization of the buildings they wanted, and to be helped and tutored with energy analysis and daylighting, with all the feedback, all the objective feedback. So they could balance where there were value judgments, they were their value judgments. So I think with the advent of very widespread use of computing, which we didn't anticipate then, which is now, that, you know, as a researcher, I don't know how to say this really. I'm not really a professional architect. I'm not an architect, but I'm much more interested in human-computer interaction. So it's just as fascinating to create a system for an architect to use, like a design computation or a topology system, which I've described. But it's also equally fascinating to create a system for a lay participant to express themselves. And, you know, looking around at the, Sean very correctly raised all the issues of political dissatisfaction caused by the current health crisis. But this sort of disconnected, what is this skyscraper suddenly plunked down in my back garden, you know, or in my neighborhood? This detachment with decision making, I can't even review, you know, or maybe with the Grenfell Tower, you know, if the participants actually knew about the materials and their fire rating and could have participated and anticipated that, it might be completely different. So I think technology, if you like, is always, could be an enabler of democracy, and it could be particularly an enabler of design democracy. And so, architects, if you like, can reframe themselves instead of being the provider of answers, to be the providers of systems that allow people themselves to provide their own answers.
There is a question from Ranchi for Sean, saying, Sean, could I ask Sean about his vision of multiple models? How can they effectively talk to each other when they are disparate? Surely there is a right cost in this, a high cost in this.
Yeah, so that I guess that follows from my previous answer. And I apologize. I recorded my talk and then had to edit it down about 10 minutes. So I apologize for cutting some things out. But some of the examples I showed, particularly the examples where there was some clustering of various street patterns and buildings and so on. There are many cases in which actually these patterns seem to fall out of the data quite naturally, and very little is done. So the case of the buildings, for instance, one of the things we notice is that it almost doesn't matter which attributes of those buildings you take. As long as you have over a certain number of them, you'll always tend to get the same neighborhoods falling out. So you have some cases in which the patterns in the data are just so clear that no matter what representation you get, it effectively is telling you the same thing. Slightly different, but enough that there would be general agreement. On the other side of things, if you have models that are particularly, sorry, my connection is unstable. If I cut out, please interrupt me. In supervised machine learning, for instance, where you actually tell the machine, this is what I want, and the patterns are brought out by labels. Well, that's an aspect essentially of training. So just in the way that we learn to speak the same language, and we learn to speak the same disciplinary language, we learn the same, when we're practicing architecture, we learn the things that are important to our discipline and so on. The same thing can be said about machine learning. I'm talking mainly about machine learning now. You can train your models to learn effectively the codes and norms of their discipline. And so effectively talking to each other is also an element of training. If I think about a system in which we have different models and we have to establish a system of trust, that is what you're asking, and that is the challenge. I don't have all the answers, but I think those are potentially two of them. One, that the patterns are already there, and one is that in crafting our models, we craft them in such a way that they have the ability to communicate the things that are relevant.
Fantastic. Okay. Thank you very much, Sean. One more question, I know, and Robert, if you can answer this in 1 minute, it would be fantastic.
Yeah, well, I'm very glad that my slightly light-hearted marshmallow comments are
yes.
beginning to sort of resonate around the conference.
Right. So is this the Marianne's Lee question? So
yes.
I'll just read the question for you, for the audience. So Robert Aish, is the invest in the marshmallow one that we know that it will be, or oversimplification of the promised land? Is the question? Oh, this is actually quite a few questions in one question.
Yes.
Is the technology one that will correlate new methods of practicing architecture, or redefine what we thought was architecture? It's like 3 questions. Okay.
Yeah, I mean, and then there's Chris Lung has got a question on retooling, and
Yes.
this is the trade-off. More retooling, more marshmallows. I mean, how do we get people to change? And I mean, we have to say that the architecture. If you read the paper, I do say, well, we know that architectural practice is under tremendous project pressure. It's very difficult to institute change under these conditions. But there should be, architecture is meant to be experimental. It's meant to be pushing the boundaries. Here are some new tools to do that. But what I would say is that, and picking up on what Sean said, some of the techniques like AI are much more applicable to defined problems in engineering areas. So the real key to attract people into new tools is to make at least the on-ramp very easy and intuitive, but not to let that dumb down the ideas or the precision thinking that flows from that. So we don't want to make sort of life so easy that you get stuck on a plateau with some simplified version, but that architects are taught, this is a building, but actually but the abstraction of the building are spaces and components that are connected. Please understand that this is beyond a simple BIM information model. This is a topological model. And if you represent your building topologically, you can make queries of that model, which will give you insights that you wouldn't do if you hadn't made that investment. So the marshmallows only come after you've made some investment in understanding how new theories can help you gain new insights into original architecture.